This is video for Math 117 1.2. I want to first start, before we do problems like this, because you can see there's going to be some factoring, is to go back and review the factoring procedure quickly. So just to remind you, you should be able to find these in your notes. If you don't have them already, go ahead and pause and take those notes. So GCF, factor formulas, grouping, and unfoiling. And then we had factor formulas from 1.1b. So these are review materials that are going to be necessary for this section. So in particular, we're going to be doing some unfoiling, and we're going to be using the factor formulas. So to simplify something that looks like this, these are all rational expressions to simplify, and the procedure is to see if anything factors. So if this was all multiplied together, this was x squared times x times negative 2 and x squared times negative 4, then I could get rid of the x squares. But because there's addition and subtraction here, I can't do that. So I can't just scratch out the x squares. It's what some people would want to do in the 2 and the 4. That's incorrect. Reducing everything has to be multiplied to do that. So here I want to factor these so everything will be multiplied. And I can see this is going to factor as x and x. And then 2 and 1. The factors of 2 that subtract to be 1. The largest one is positive. So that's how that factors. And then this is a difference of squares that comes straight off of a factor formula, x minus 2, x plus 2. Now things are multiplied. So this factor can reduce with this factor, and I'm left with x minus 1 over x minus 2. There's x's and y's running around all over the place here, but I want to factor out greatest common factor is what it looks like. So the xy comes out and I'm left with 3xy squared minus 2, and the xy comes out on the bottom and I'm left with 4y. If I reduce this now, everything's multiplied. I can reduce this and I'm left with what's left in the parentheses here. On the next problem, I'm going to have to multiply these two, so I'm going to do in my aside method. So I multiply the 9 and the 2. It's a trinomial that has to be factored, and I end up with 18. So I need the factors at 18 that subtract to be 3. That's 6 and 3. Largest one is negative, negative 6, positive 3. And then I'll divide out the 2. That was the thing that I multiplied to begin with. So I end up with these factors. This reduces to 3. This doesn't reduce, so the 2 comes as a coefficient for the first term in that parentheses, which is a. The bottom is going to factor, I can see where the b squared is going to come out. And I'll be left with 2a plus 3b. Ah, look at that. So these reduce, everything's multiplied now. So my answer is a minus 3b over b squared. The last one here, I can see there's a 3 that factors out first, so let me do that. 3, and I'm left with 4t squared plus 4t plus 1. And that matches one of my perfect squares. This is a perfect square, that's a perfect square, and the middle term is 2 times a times b. And the bottom factors as 4t, that's going to factor as 2t, difference of squares, minus 1, and 2t plus 1. So the top I said factored as 2t plus 1 squared, but let me write it as 2 factors so I can see a little better what I'm doing. My t's have a little bit of a curl on the bottom so I can tell the difference between the positives and the t. Now make sure when you're doing WebAssign, if it has a variable t, that you're actually putting in t's, and if it's lowercase, it has to be lowercase t, uppercase has to be uppercase. So then I'll write 2t minus 1, 2t plus 1. This is going to reduce, and I'm left with 3 times 2t plus 1 over 2t minus 1. And you could multiply that back out, but it's not necessary as far as I'm concerned. In this section, we also need to do some multiplication, division, addition, and subtraction of rational expressions. So I can see if I multiplied all this, it would be an absolute mess. So really, when you're trying to simplify, you should simplify by factoring first, and then reducing as you can, and then multiplying out if you need to. So x minus 6x plus 9, that's a square and a square there, and the middle term is 2 times the others. So let me show you what I mean. X minus 3 times x minus 3. So checking this with the formula says a plus b squared, well, I'm looking at a minus b squared, should give me a squared minus 2ab plus b squared. So I'm checking this form to see if this works. My b is 3, and my a is x. So I should have 3 times 2 times x times 3, and that gives me the negative 6x in the middle. So that checks. So this actually is what I needed. And if I fold this back out, I do get this. That's all I'm interested in when I'm factoring. Does it work? I noticed here there's a 3 that factors out, so look for common factors when you do this. When you're trying to simplify these rational expressions, and multiplication is really important because there's a lot of steps to it. So the factors of 6 that subtract to be 1 are 3 and 2. Largest one is negative. And then over here I'm multiplying, so I'm multiplying straight across here too. You might need to do the 2 times 3 here, but I noticed that this is going to give me a 2x and an x. I've got a 3 and 1, so I either need a 3 here or a 3 here. And I think I need this one and a 1. Signs are different. So I could have done the multiplication. 3 times 2 is 6. So we have x squared minus 7x plus 6. I would have gotten x minus 3, x minus 2. And then I would have had to divide out the 2. So this would become 1, and that would become 3/2 and 2 again. But I just noticed that I made a mistake. I needed the factors of 6 that added to be 7, and that's not 3 and 2. That is 6 and 1. And I kind of caught that mistake because I'm realizing that this is what I needed. So 6 divided by 2 would give me that 3, and the 1/2 would put the 2 out front. So it does check. So as a check, I can see that what I have factored over here actually does work. Now, one at a time, I feel like I'm Zorro here. One at a time, I'm going to scratch out one that matches. And I had a student at one time that said these were birds and bats. If you have a bird on the top and a bat on the bottom and they match, they fly off together. So there's an x minus 3, x minus 3. Here's an x plus 2, x plus 2. And I'm left with an answer of 3 over 2x minus 1. So that's simplifying with multiplication. Now, simplifying with division is almost exactly the same, only division is the same as multiplying by the reciprocal. So this actually means, and I usually don't write it twice like this, but this time I'm going to, and you might always want to. So before I do any work at all, I'm going to get rid of this division, because division is the same as multiplying by the reciprocal. So we end up with x squared plus 2x minus 3 over x squared minus 1. Now we're back to working the same kind of problem we had here. So I know the factors of 3x squared plus 2x plus 1 minus 1 is going to give me 3x and x. And the 1's how I get the 1 there. And I'm going to need a positive here and a negative there. You could do the aside procedure if you want to. But basically I'm just trying the signs. I need a 3 minus 1 gives me 2. Outer and inner. 3 minus 1 gives me the 2 I needed. Alright, same thing here, x and x. Factors of 3 that subtract to be 2, that's 3 and 1. And the largest is positive, negative. And then underneath I have 2 times x plus 3. And x squared minus 1 is difference of squares, so that's x minus 1 times x plus 1. You should be able to do this just as quickly as I do if you've studied your factors procedures. So it should not be difficult for you at all. X plus 1, x plus 1. I think you did a lot of this factoring when you were in probably 9th grade, maybe 10th, in Algebra 1. X plus 3 factors with an x plus 3. X minus 1 goes away, and we're left with 3x minus 1 over 2. So that's what I would expect to see as your answer if I gave this to you when I give this kind of problem to you on the test. Now the next is addition. So be aware when you're doing multiplication. I really think multiplication and division of rational expressions like this, of fractions, is easier than adding and subtracting on one level. To me, they're about the same level of difficulty, but some of you have more trouble with this. So I need an LCD if I'm going to add or subtract. So 3a, 5b, they don't share anything, so my LCD will just be multiplying by the other one's denominator. So I'm multiplying by the number 1 to change their names, and this is like a family reunion. When I go to a family reunion, I'm a sister, I'm a daughter, I'm a granddaughter, I'm an aunt. I have aunts, so I'm a niece. Here I'm going to have 3a over 3a. So now these two relate. They have the same denominator. That's like the same last name. It's almost like adding inches and yards. I have to convert things so that I can actually add the same units. So the same units here mean the same denominator. So if I multiply this, I get 5ab plus 5b plus there, 3ab minus 6a. So I'm just distributing this to both of these, being careful of signs, all over 15ab when I multiply this out. They both have 15ab. It's like both of them are in inches now. They're both in the same unit. Now I can see there's nothing that I can simplify here, so I'm done with this. There's no a that I can pull out because not all of them share an a, not all of them share a b, so and they don't share the same numbers. So I'm done with that. I don't like it. It looks less simplified to me than the original did, but I don't have to like it for it to be right. For the next problem, I can see I'm having subtraction here, and they have different denominators. So let me factor them first. X minus 3, x plus 3. That's how that one factors. And this factors as x minus 3 times x minus 3. So the LCD is what when I multiply out, I end up with the smallest amount of factors that will get me both of these. So that means I need an x minus 3 and x plus 3. And I only have one x minus 3, so that means that I'll need to put another one in to get this. So my LCD should be x minus 3 times x plus 3 times x minus 3. So both of these are in there. That gets my LCD. So over here I'm going to need an x plus 3. Sometimes this is an exercise in how little can you write in order to get it right, because the more you write, the more complicated it gets, and the more time you spend writing and the more errors you might pick up. So over in this one I have both the x minus 3 and x minus 3, and I need an x plus 3. I'm just throwing in enough to make them both have the same denominator. So now I know, because I factored these, that these have the same denominator. So the denominator is just x minus this, the x minus 3 times x plus 3 times x minus 3. So I'm going to have 4x plus 12 minus, now this minus 5 is going to have to be distributed, so I have minus 5x minus 5 times 3 is minus 15. All over x minus 3, and I could put squared here, or I could just write it twice. So I've changed the units. That's what my new units are. A new denominator. So let me collect like terms in the numerator. I have negative x, and 12 minus 15 is minus 3. All over x minus 3 times x minus 3 times x plus 3. Now, minus x minus 3 does not reduce with x minus 3. This actually equals this is the same as writing negative of x plus 3 if I factor out a negative. So I can reduce this negative x minus 3 if they're exactly the same signs, but exactly the same numbers, but opposite in signs. Then I can reduce these and be left with a negative 1. So my answer will be negative 1 over x minus 3. And I could write square here, and that would be fine. For the next one, I want to get rid of the complex fraction, which means I want to get rid of denominators in the numerator and denominator. So extra denominators here I want to get rid of. So I need an LCD. So what I do for an LCD is I put the first one in, and then I'll look for any other denominators, this one, and I already have it, so I don't need to put it in again. So I'm multiplying the top and the bottom by this new denominator, by the LCD. So now I'll distribute this, and I'll end up with x times 1 gives me x. X times 1 over x is just 1. X times 1 gives me x minus x times 1 over x is 1. And that's as reduced as this gets. That's all you have to do there. Doing the same thing with number 10 here, I see my LCD is actually x times y. It contains an x, it contains a y, and it contains xy. So I need xy. I'll distribute the xy. I got xy times divided by x would reduce an x, so that means I'm left with y. xy divided by y would reduce to y, which means I'm left with x. So I need a plus x here. And then xy here is going to be xy times 1 is xy minus. The xy's will reduce here, and I'll be left with 1. And that's as reduced as I can get that expression. We have a couple more topics that we need to cover in 1.2. Here, I want to remind you of the conjugate trick. If I have 1 over 1 plus the square root of x, if I multiply by, this is a plus b, if I multiply by a minus b, what I call a conjugate, if I was looking at complex numbers or imaginary numbers, this would definitely be called a complex conjugate. But here I'm using this as a trick to get rid of the square roots. So when I multiply these out, I end up with 1 minus x here, 1 minus square root of x on the top. So now I want to multiply just enough to get rid of the square root here. If we just had 1 over the square root of 3, we would multiply the top and bottom by the square root of 3. But we don't have just that. So we need to multiply by enough to get rid of the radical in the denominator. We're rationalizing denominators. So that'd be square root of 3 plus 1. Square root of 3 plus 1. I'm multiplying by the number 1. The numerator is real fast, square root of 3 plus 1. The denominator is 2, but I want to think about what this is. Foiling would give me a square root of 3 times square root of 3, which is 3. Square root of 3 times 1 is square root of 3. And then square root of 3 times negative 1 would be minus square root of 3. So the outside and the insides are going to leave off that middle term. They're going to cancel. And then it'll be left with minus 1. So I don't have to think about that every time. That when I do this trick, I'll automatically do the first one squared minus the second one squared. So the first one squared will give me 3. Square root of 3 squared is 3. Minus the second one squared, 1 times 1 is 1. So this gives me square root of 3 plus 1 over 2. And you could distribute this and write this as square root of 3 over 2 plus 1/2. For the next one, think about what the conjugate would be here. See if you can do it on your own. Pause for a moment and see if you can do it on your own. 1 plus square root of a. 1 plus square root of a is what's going to get rid of the radical in the denominator. Now if I multiply this through, I'm going to get a plus a squared. And I could have left it and just written a times 1 plus a. The first one squared is 1 minus the second one squared is a. Same thing here. I want to rationalize, so I'm going to multiply by just enough to get rid of the radicals in the denominator. And that would be square root of x plus the square root of y, both on the top and the bottom. This is the number 1 I'm multiplying by. Nothing but a simple little trick there. But what I'm deciding to use for my number 1 is important for this conjugate trick. So that's where it's coming from. So it's important that you understand how the conjugate trick works in order to do this really quickly. I'm making it look easy because it is easy once you understand what the trick does. So the first one squared would just be x minus the second one squared would just be y. I can FOIL it out and I'll see I'll get square root of x times square root of x is x. I'd have a plus square root of xy minus square root of xy, middle term goes away, minus square root of y times square root of y is y. Now this first chapter that we're working on has a lot more stuff in each one of the sections because it's a review of pre-calculus and we do it really quickly. The rest of the semester we'll have a couple of little topics introduced in each section, and in some ways it's simpler, but it is new material, things you would not have seen. I want to remind you that the word OR means union and AND means intersection. So when I have you solve inequalities, I'll expect it to be solved in 3 ways. I want number line, interval notation, and the actual solving for x here. So you'll see those, the inequality. That's what I mean by solving for x. So if I solve for x here, I'm going to add subtract 4 from both sides. I get 2x is less than 4, and then I'll divide by 2. So I end up with x is less than 2. Easy enough, right? On a number line, this would be an open circle. And notice that if you have x on the left side, it shows you which way you should fill it in. Less than is open circle. Greater than or equal to, less than or equal to is a closed circle. So there's my number line. So I have my inequality, my number line, and I also need this in interval notation. So it's coming from what's back here, which is negative infinity, and it's going to 2. you cannot write 2 to negative infinity. Write this backwards because that's incorrect. This is basically walking along the number line in the correct direction. If we do the next one, remember that if you have an inequality and you divide or multiply by a negative, you have to reverse that inequality. And oftentimes I'll write through it like this to remind myself. So this is x is less than or equal to a negative 5. So putting that on a number line, that's a closed circle, and I don't need a whole bunch of tick marks. Negative 5 is good enough. We're going this way. And then it's negative infinity to negative 5. Closed circle means that I'm going to use a bracket. This one is a three-sided inequality. That's actually an and or an intersection of two inequalities. So when we do this one, anything we do to one side, we're going to do to all three. So to get the x by itself, that's what we mean by solving. Get the x by itself. I'm going to add 2 to all three sides. And I end up with a negative 4. If you need to pick up your calculator for this, make sure you do. Is less than x is less than 4 plus 2 is 6. So when I draw my inequality, when I draw my number line here, here's my inequality. So I've solved for that. When I draw my number line here, I need these in order, negative 4 and 6. I want them x to be in between those numbers. That's what this notation means. It's going to be greater than negative 4. If I read it this way, x is greater than negative 4. Reading backwards, x is less than 6. Negative 4 is less than x. So x is bigger than negative 4, which puts me over here. So I'm looking in here between 4 and 6. Less than is an open circle, and both of them are less than. So that means this interval is from negative 4 to 6, just like that. This should be really simple. Don't make it difficult. Study it well, come back through it, and review it again if you need to. This or means a union, so x is greater than 4. X plus 1 is greater than 4. I'm going to subtract 1, and I'll have x is greater than 3. X plus 2 is less than negative 1. I'm going to subtract 2, and I'll have x is less than negative 3. So this is telling me that I want to keep both of these. A union means keep. This means keep both, or all three, or all four, or however many there are. So on my number line, I'm going to put these in order. Negative 3 comes before 3. And it says I want x greater than 3. That's an open circle, and it's greater than 3. X is less than negative 3, open circle, and it's less than negative 3. So I have it solved, and I really need the or in there. I have it solved with an inequality, and then I also have it solved with a number line. Now I need the interval notation. So this is negative infinity to negative 3. The symbol for the or is union, and it's that symbol. And on WebAssign, over on the side, if you look in symbols, you can find both the infinities and the unions. Actually, I think this one is in set notation. And then we're going to go 3 to infinity. Same thing on this one, but this says and. And means intersection, so let me be a little bit more careful with this one. This says x, I'm going to subtract 3, is greater than negative 2. And this I'm going to add 2, x is less than or equal to 2 plus 1 is 3. So it's saying negative 2 to 3. So I have to have both of these statements true. X is greater than negative 2 would be here on with an open circle. X is less than or equal to 3 is a closed circle and back. And you can see the things that I intersected here, the things they both shared were in between. So ands often are in between 2 points like this. So my interval notation would be from parentheses negative 2 to 3, close the brackets. The last of our inequalities here has a couple of things multiplied. So we're going to basically use the zero product property combined with some inequality stuff to get the answers here. So what I know for sure is that it's going to be equal to 0 when these factors are 0. So that's x is equal to negative 3 or x is equal to 5. So I have to determine what's happening on my number line when these factors are 0. So basically, I need to put these numbers in correct order on the number line, negative 3 and 5. I want to have the multiplications, the products that are going to give me something less than 0. And I could try a number in each of these intervals. So before -3, something like -100, that would give me a negative and a negative. Negative times negative gives me positive. So I end up with positive here. So this is going to, if I graph this, it's going to give me something above the number line. And we will graph it so you can see a way to do this. Between -3 and 5, I notice zeros in here. So if x's went away, I'd have -3 times -5 gives me -15, which is less than 0. So that would give me a negative in here. And for greater than 5, like 6 minus 5 gives me a positive. 6 plus 3 gives me a positive. Positive times positive is positive. So what I know for sure is that it's positive in this interval and positive in this interval, but I want the negative ones because less than 0 means negative. So this is my solution set in here. I can also have it equal to 0, so then I have to choose whether I want open or closed circles, and equals means that I can include the places that make it 0. So my solution set would be here from -3 to 5, including those. So let's go to the calculator and see what this looks like if I put this into y equals. So in y equals, I'm just going to write x plus 3 times x plus 5, parentheses, x plus 3 times parentheses x minus 5. And that is x minus 5. I want to do a zoom 6 to graph this. Now I don't really care what the graph looks like. I just want to see that the graph itself, the part that I want to keep as my solution set, is the part that's below 0. You can see that this part down here is below the x. Now all I'd have to do is switch this and make it greater than or equal to, and I'd be wanting these two pieces, and I'd have to do a union for those two pieces. Now we're looking for the x values, not the y values. So the x is between -3 to 5. That's what we see there. So trying the second one, and you want to pause for a second if you kind of understand what you're doing here, and make sure that you can do this by hand. Of course, you can use your calculator too. So looking at this, I see that x has to be equal to 3/2, or 1 for my critical points. 3/2 is bigger than 1. So on my number line, I'm going to put 1 and 3/2. I'm going to check in between. Zeros over here. 0 is less than that. So if I put 0 in, I have 0 in both of those places. So I end up with -3 times -1, which is positive. Between 1 and 3/2 is like 1 1/4, and that's going to be negative if I put that value in. And between 3/2 to infinity, anything I put in is going to give me positive in those two. So I'm just checking signs. Go back over these again if you need to. It's really easy because we're only putting numbers into them to see what the signs are going to end up being. So here I'm interested in the ones that are greater than 0, so I want the positive ones. Those are greater than 0. I want greater than 0, so I can't include the endpoints, so those are open circles. And I'll scroll through like that, well, squiggle through like that, and I end up with shaded areas. So this is going to give me an interval notation, -infinity to 1, union 3/2 to infinity. To be sure that I understand that, I put it in my calculator. So in y equals, I'll put in y1, 2x minus 3, x minus 1, and then I'll just graph. Now if you need to, do a zoom 6 so that you can have it in a standard grid. And I can see it's really hard to see exactly where that is, but the ones that are bigger than 0 are the things above the x-axis. I could zoom in some, zoom 2. It'll show me a little better where that is, but I still can't see that that's actually 3/2. I'd have to do a little bit more to do that. So you definitely want to be able to solve these for 0, and then you'll be able to clearly see which pieces you want to keep. So I wanted greater than 0, I'm keeping -infinity to 1 and 3/2 to infinity. There are a few problems towards the end of the 1.2 homework that kind of look like this. They're asking you for a minimum C, or they're asking you to find intervals. So I want to go through these problems. They're not too difficult to do. I'm going to need my calculator for some of the multiplication. So I'll get to my main screen and just clear it off so I have a nice clear screen to work with. So the first thing I'm doing, minimum C, means I want to find what C is going to be and then figure out what the minimum will be. 7C minus, I need 18 times 7, and that's 126, is equal to 2.8, is greater than or equal to 2.8 plus 1.7 C. Now I'm collecting like terms, so I want the C's on this side, minus 1.7 C, minus 1.7 C, and I want the numbers on the other side, so I'll do plus 126, plus 126. So this will give me 7 minus 1.7 will give me 5.3 C. If you need to, pick up your calculator. Hopefully I did that correctly. Is greater than or equal to 2.8, and 126 will give me 128.8. So I'll do 128.8 divided by 5.3, and that gives me 24 point. And now I want 3 decimal places on your test, 3 decimals. Sometimes WebAssign is going to have you do more or less than that, but I want always 3. So you want to write that down and remember it. So 24.302. If the 4th digit here, wanting 3 decimals, if the 4th digit is bigger, 5 or bigger, then I'm going to round up. Otherwise, I can just get rid of all those decimals afterwards. So this would be 24.302. So C is greater than or equal to 24.302 degrees. Now I want the minimum C, so 24.302 would be the minimum. For the next problem, I want an interval where C is between -8 and 23, and they give me a formula. So I want to find F, so I'm going to make a substitution for C. So -8 is less than 5/9 times F minus 32 is less than 23. All I've done is substitute this formula in for C. So to solve here, I'm going to get rid of the 5/9, I'm going to get rid of the 32, and I can get rid of the 5/9 really quickly by multiplying all 3 sides by 9/5. And that's going to go away. So I'll be left with -8 times 9 is -72/5 is less than F minus 32 is less than 23 times 9. Can't do that one in my head. 23 times 9 is 207, and I'll go ahead and divide that by 5. That gives me 41.4. So this one over here, 72.5 divided by 5, right? 72 divided by 5 is going to give me 14.4. So I'm going to be adding 32 to each. So I have negative 14.4 plus 32 gives me 17.6. So 17.6 is less than F is less than 41.4 plus 32 is going to give me 73.4. So there's the Fahrenheit degrees. You can put degrees in here, but oftentimes in WebAssign they put those in for you. I don't require them on the test. Sometimes I get bonus point for correct units on the test. But on this first test, we have enough going on that just being able to do the test will be fine. Now to find C here, we actually need to get this back to what C is. So to change this to a Fahrenheit, the first thing I want to do is add 32. You actually could go to a converter. There's lots of converters for centigrade and Fahrenheit online, so you could convert these back and forth if you wanted to. So this is going to give me 86 is less than F plus 32 is less than, what is that, 93? And then to get the next part of the formula, I would need to multiply all 3 sides by 5/9. So now I can write that this is C in here. So 5/9 times 86. 5 divided by 9 times is 47.778. And 5/9 times 93. I get 51.667. So that concludes all the kinds of information you're going to see. There's some true false on your 1.2 exercises that I didn't show you, but it's going to include all the stuff that you would possibly see on 1.2 homework. Please see me at my office hours or ask for an appointment if you're having difficulty with the assignment.